afternoon, everybody. I would like to tell you about construction of risk management system based on SAS platform in the public operated RGD. Do you hear me?
Can we use this one?
Doesn't work.
This one works.
Okay. I would like to tell you about construction of risk management system based on SAS platform in the Russian railways. Under present-day conditions, dependability and safety requirements of railway transportation are constantly rising. The market competition with other types of transport calls for maximum safety of transportation process, excluding external and internal negative influence. During the last 3 years, Russian Railways has carried out large-scale scientifically applied work on creation of the efficient infrastructure management methodology based on economical criteria, dependability and safety parameters at all stages of life cycle. Initially, we used principles of reliability, availability, maintainability and safety for short RAMS, methodology developed in Europe. What is RAMS? RAMS answers on 4 questions. First of all, how often does failure occur? What operation facility volume is given at the disposal? How well badly can the system be maintained? And what are consequences of some events? Initially, RAMS focused on manufacturers of technical facilities that didn't satisfy the purposes of the Russian railways, that concentrate mainly on operational activity. It has led to the necessity for development of operational dependability and safety parameters of facilities of railway transport, coordinated with volumes of performed operational work. As a result, RAMS was transformed into a new project, УРРАН, which means Resource, Risk and Dependability Management. УRRАН bases on parameter system including dependability, which means reliability, availability, maintainability, plus durability, safety and resource parameters. The basic purpose of УРРАН application is the optimization of maintenance management, providing the demanded level of operational dependability and acceptable level of risk. On this slide you can see 5 main differences between УРРАН and RAMS. First of all, transition from management of facilities into management of dependability and safety of technological process. Dependability and safety management of technological process on the basis of the developed system of operational dependability and safety indicators. Investments management on the basis of risk estimation, view of life cycle cost, durability and maintenance of railway transportation facilities according to the actual state. Management of the company capitalization due to economic efficiency enhancement of infrastructure maintenance. Expense justification for reconstruction, modernization to supervising ministers and departments. УРРАН provides interaction between infrastructure, financial section, failures and transportation. Normative methodical base of УRRАН system is carried out in 3 directions: reliability management, risk management, resource management. The national standards GOSTAR 54504 and GOSTAR 54505, developed in 2011, established a set of requirements which essentially changes decision-making system and allows passing from administrative methods of management to the methods based on risk estimation. During the next 2 years, it's planned to issue 2 international standards, 6 national standards, 12 standards of the organization, and 38 documents of methodical orientation and manuals. All taken decisions on facility management are directly associated with risk management. The slide presents traditional definition of risk according to the international standard IEC 62278 and GOSTAR 54505, functional safety, risk management on railway transport. It's very important that in GOSTAR 54505 the following postulates considered. Absolute safety doesn't exist. After acceptance of protective measures, there is always some residual risk. Safety is reached by risk reduction up to the acceptable risk level, defined as tolerable risk. There's a necessity of revision of an acceptable risk level during life cycle. On the basis of the developed standards, we have carried out work on risk assessment of injury rate of pedestrians on railway pedestrian crossings. At the first stage, key parameters influence injury risk occurrence were defined. Layout, crossing equipment, characteristics of train operation. Next, the detailed event tree for risk assessment was constructed and probabilities of injury rate were defined. Then the risk matrix of injury rate was generated. It displays a combination of injury event frequency and the amount of consequences. At the last stage, recommendations on risk reduction depending on risk class were generated. The carried out work has allowed to define necessity of re-equipment of existing pedestrian crossing on track Moscow-St. Petersburg. Representation of risk estimation results in the form of risk matrices evidently allows to apply them for risk estimation of levels according to operation parameters. In this case, risk deviations from requirements of railway maintenance depending on its traffic density are estimated. In 2011, the automated system УРРАН was launched. The automated system provides data gathering from branch automated system according to facility characteristics of the infrastructure, data given under the account of their failures, then calculation of parameters and levels of facilities carried out. Next, the aggregated and detailed reports according to the dependability of infrastructure facilities for all railway network. Structural division or separate infrastructure are formed and given to users. At the following stage of automation, problems of planning are solved and estimation of repair results of infrastructure facilities is performed. SAS software has been selected for development and operation of УRRАН system, which has been successfully used for solving problems for Russian railways during the last 10 years. SAS platform has provided effective integration of branch systems, diverse data, an opportunity to operate data bulk, and construction of an illustrative user reporting, including facilities of geoinformational system. At the SAS УRRАN development, the wide range of components from SAS platform have been used. Besides, the specific product SAS EGRC solution has been purchased, which provides a toolkit on management of operational risks and will allow to use it in the further development and automation of УRRАН methodology. Introduction of SAS УRRАN at the end of 2011 has allowed users to make decisions on facility dependability estimation of railway equipment. SAS УRRAN reports has allowed to estimate the general state of railway dependability of the whole railways network. This report shows the general estimation of track facility state on railway divisions according to their dependability parameters for the period under consideration. And this report shows the failure rate of track equipment of network division track facilities for the period under consideration. This report shows kilometer by kilometer estimation of track facilities, reliability for the considered period with binding to the digital layout of the railway. And in the end, result analysis of repair work carried out according to the current technology and to УRRАН methodology. Results of УRRАН methodology and the automated system SAS УRRАN have allowed to optimize and increase the quality of carrying out track repair work on the Northern Railway. Thus, the efficiency of new methodology application in comparison with the current traditional technology of an infrastructure management have been obtained. First, on this slide you can see current state, the track infrastructure between Yaroslavl and Arkhangelsk. The second, work plan according to the current technology, where repair work has been done on track section which didn't need repair. And the third, work plan according to the УРРАН technology. As you can see, there is no any red areas, just what we wanted. The primary uses of the automated dependability management system and the factor analysis of traffic safety state are the central and regional boards of administrators of the Russian railways. The structural divisions which are directly carrying out works on infrastructure maintenance and arrangement of transportation. In addition, one of the main users of the system is the Situational Center for Monitoring and Management of Emergency Situation of the Russian railways. This Situational Center was established in 2010. The Situational Center is intended for consolidation of gathering and processing data connected with the state of train operation safety, transport and fire safety of railway transport, external natural factors influence on transportation process. In addition to risk estimation connected with general dependability of infrastructure facility, the task of Situational Center includes traffic safety of train operation, which depends on a lot of factors and processes. For general monitoring and the traffic safety analysis, the development of specialized program XRC is conducted for the Situational Center. XRC development is also based on corporate data warehouse on the basis of SAS platform. The program represents a number of reports on general estimation of traffic safety state on the railway network and railway divisions. It allows tracing dynamics of change of traffic safety state in view of accepted measures. This report shows the general state of safety level of facilities and sectional view of railways for the considered period. Another report shows the general state of safety level of facilities and sectional view of predicted events and railways for the considered time period. Duly obtained current state and forecast data of traffic safety allows to reduce risk level and prevent infringements. As a result, the program XRC and УRRАН application users of Situational Center and structural divisions in the automated mode receive the detailed plans for traffic safety and dependability management of transportation process. At present, the risk management system, which integrates organizational structure, the normative methodical base, the software, is under construction in the Russian railways. It's important to point out that SAS platform and active involvement of the Russian division and SAS company have played a considerable role in the development of the given system. And the last, now I have to say thank you very much for your attention. Any questions?